We are living in the era of the green rush. From the boardrooms of London to the highlands of Kenya, the world has made a pact to plant our way out of the fire. We've been told that every sapling is a soldier in the war against carbon. But what if our maps are wrong? What if a forest in the frozen north is actually an accidental heater, while a forest in the tropics is a cooling miracle? Today, we're dissecting an interesting study from ETH Zurich, which is one of Switzerland's premier universities that turns global climate policy on its head. Nora Fahrenbach is a PhD researcher at the ETH Zurich. She and her team of researchers conducted research on the effects of reforestation across the globe by building a digital earth on a supercomputer to see how the planet actually breathes when we change its skin. It turns out, in the fight for the planet, location is such a big detail, almost an entire game. My name is Steve Mokaya, and this is the Nature Trail podcast.
Yeah, so the motivation of the study was really because almost every country nowadays has net zero targets. And so that means that we don't just have to reduce fossil fuel emissions, but we also really need to remove the remaining CO2 from the atmosphere. And their countries are putting great hope into reforestation projects. But our question was kind of, how would the Earth actually respond if we plant that many trees? And so to answer these questions, we ran a climate model. You can think of that like a digital Earth on a supercomputer. And we implemented different proposed reforestation scenarios. And what we found and what really amazed us was that the sheer number of trees isn't really the deciding factor. Our results show that where we plant trees is just as important or even more important than how many we plant. And so what we see is that with strategic reforestation, we can achieve the same global cooling effect using only half the land area. So to put this into perspective, that would save us an area the size of the entire European Union. And so that is, of course, very important because we want to make reforestation not only as efficient as possible, but if possible also use as little land as possible, since land is a very precious resource that we also need for agriculture and cities.
For a moment, think about the vast, wide expanses of Siberia, Alaska, and Northern Europe. For millennia, these snowy plains acted like a mirror, bouncing sunlight back into space and keeping the Earth's fever down. But then we started planting trees.
In high northern latitudes like Siberia, Alaska, or the central USA, there we have a warming effect due to the color of the trees. So what happens is that a dark forest swallows much more sunlight than a bright, snowy surface, for example, and that can lead to warming. That's quite similar to when we wear a black t-shirt in summer, you heat up much more than in a white one. And so because of this color-based effect, this can partially or even entirely cancel out the CO2 cooling. And so reforestation there can potentially even lead to warming, which is not what we were wanting originally. So basically what is happening is that usually the snow doesn't land on the tree, right? The snow kind of falls down from the tree. So if we don't reforest, we just have a snowy surface. But if we reforest, we have a dark forest over a snowy surface. And so, while snow naturally reflects a lot of sunlight and cools, this dark tree over the snowy surface will absorb sunlight and warm. And that's why this effect is much more prominent in the high northern latitudes, right? Versus the evaporation effect is much more prominent in the tropics because there naturally it's very warm. And so when the trees release water, this will evaporate and will lead to cooling.
It is a scientific gut punch. In the global north, the albedo effect, which is the planet's ability to reflect light, is being strangled by the very trees we thought will save it. In these regions, a tree's dark canopy can actually cancel out its own carbon scrubbing benefits. But move your finger down the map to the equator, to the Congo Basin, the Guinean forests, the Eastern Arc Mountains, and the mighty Amazon rainforest in South America. Here, the rules of physics change. Africa in particular, and the areas along the equator in general, don't have the snow problem. Instead, they have a double cooling superpower.
So what we see regarding regions is that from a climate perspective, reforestation really makes much more sense in the tropics, like the Amazon basin or large parts of Southeast and West Africa. Because trees kind of provide almost a double cooling effect there. On the one hand side, they cool through CO2 absorption, but they also cool through high evapotranspiration. And that basically means that trees release water and that then evaporates and cools. That's quite similar to when humans sweat, and this evaporation provides direct cooling to the surrounding area. And because of those two effects, the CO2 effect and the evaporation effect, reforestation in the tropics really helps to cool the local and global climate. And so if we focus on reforestation in the tropics, it can become a far more efficient tool for climate protection.
Africa is home to some of the world's most effective natural cooling engines. Reforestation here delivers the strongest climate benefit for the planet. Every hectare restored in our soil is twice as valuable to the global thermostat as a hectare in Canada. But being climate gold comes with a warning. There is a temptation to plant fast, to plant cheap, and to plant for profit. We've seen it with eucalyptus, a thirsty invader that has marched across Ethiopia, South Africa, and Kenya.
What is very important to consider is that we definitely have to avoid very fast-growing monocultures, which might only suck up the very precious groundwater and further increase fire risk. There has been, for example, huge problems with that in Portugal, where they planted a lot of eucalyptus, which is not very local to that region at all, and has very high fire risk. So this is kind of what should be avoided, and instead projects really have to prioritize native species. This is even more important in Africa because those native species will be naturally adapted to the local, usually very warm climate, and will be much more resilient to heat waves, and further will be very good at using water, right? If you plant potential not very native trees, they might need much higher water quantities than native trees which are used to the dry conditions.
Portugal is the cautionary tale. They traded the native landscapes for eucalyptus only to be met with devastating wildfires and drying up rivers. For Africa, Nora says that native species are the only resilient choice. They know the local sun and they can put up with the droughts. This study raises a massive and avoidable question on global justice. If trees in the north are less effective, should the global north stop planting and start paying?
Absolutely. So I think there's 2 points to this question. On the one hand side, it doesn't at all mean that higher northern latitude countries shouldn't do anything, right? Higher northern latitude countries can, for example, still focus on re-wettening wetlands. So there's quite a lot of degraded wetlands in the US, in Europe, and they basically lost their ability to store carbon dioxide and now even emit carbon dioxide and methane, which is much more potent than carbon dioxide. Another way is restoring grasslands, because grasslands are actually quite good at storing large amounts of carbon underground to soil. And we can still also focus on planting trees in cities in those regions, just not in like a very large scale, because it will also help to reduce the temperatures in the cities. So those 3 things are kind of options that, say, the USA or Europe can do, which also will help with global climate change. Another point you mentioned is that, if there's some kind of financing option, and so recently since COP30, there's the Tropical Forest Forever facility, and I think that's a first step, at least in the right direction, where the idea is to treat a standing forest basically like a high-value asset. This kind of facility the idea is that it provides countries with a fixed amount of annual payment for every hectare of forest they keep alive. And lots of higher, developed countries in the higher northern latitudes already contributed to that. And that would maybe be one option, how those countries can still help with reforestation in the tropics by giving the financial support, and that then allows locals in those countries to really take care of the forest and make sure that there's no deforestation.
Beyond the climate models, there is the reality of the people who live on the land. In Africa, forest loss is largely driven by agricultural expansion, farmers clearing land for food and commercial plantations. Nora says that reforestation doesn't have to mean the end of farming. Instead, it looks at a model of integrated land use.
In Africa, for example, lots of deforestation is happening because of agriculture expansion or city expansion. And so one way to prevent that deforestation might be to make a standing forest much more valuable than a clear deforested field. And so for agriculture, one way would be to promote things like forest farming or understory cropping, where the idea is really that farmers would grow very high value but shade tolerant crops like cocoa, like medical plants or wild coffee under the canopy of the existing rainforests. And so this on the one hand side really helps to preserve the cooling of the forest, but on the other side also helps to provide a sustainable income to communities, which then will help to prevent the deforestation happening in that area.
This approach, known as forest farming, allows the standing forest to remain intact while providing a sustainable income for local communities. For areas where the trees have already been lost, the study points to agroforestry, the practice of mixing trees with food crops.
If an area is already deforested, on the other hand, maybe we can move more towards agroforestry, so the idea of mixing trees or reforesting, but also planting food crops. And that can help, for example, to restore the soils and will also give the farmers an income while also encouraging them to reforest those areas.
It is a strategy designed to give rural economies a direct financial stake in the success of reforestation. The data from ETH Zurich provides a sobering limit on what nature-based solutions can achieve. Even under the most optimistic reforestation scenarios, the maximum global cooling reached by the end of the century is 0.25 degrees Celsius.
What I would like to mention here is that we shouldn't see reforestation as a silver bullet against climate change. What we see in our calculations is that even in very optimistic reforestation scenarios, we can cool the Earth by a maximum of 1/4 degree by the end of the century. Since we're at the moment fighting for every 1/10 of a degree, that is a very valuable contribution, but it also makes clear that we can't plant our way out of this climate crisis, right? Reforestation can only ever support, but not replace rapid reduction of fossil fuel emissions.
The study concludes that while tropical forests are essential tools for local cooling and carbon storage, they are not a substitute for global industrial change. The findings suggest that while Africa holds the climate goal in its forests, the trajectory of the planet's temperature still depends on the speed at which the world transitions away from fossil fuels. My name is Steve Mokaya. This is the Nature Trail podcast. Many thanks for your company today.